We are going to look at multiplying fractions with pictures and with standard algorithm today. So, on the first one, it says, which model represents 3/5 of 15? So the very first thing you're going to want to do is look at which one of those answer choices has a total of 15 little rectangles. Does F have a total of 15?
Yes.
1, 2, 3, 4, 5, 6, 7,
Yes.
8, 9, 10, 11, 12, 13, 14, 15. Yes. That's a possibility. Does G have a total of 15? No.
That's
So right off the bat, I'm getting rid of it. Does H have a total of 15?
Yes.
K and J?
Yes.
Yes. Okay, so I have now down to 3 answer choices. Okay, now, do you remember when we multiplied decimals?
Yes. No.
When we multiplied decimals, we had equal groups with the same amount in each group.
Yes.
Okay? So fractions is the same way. On F, do I have any equal groups going on there?
No.
Do I have groups at all going on F?
No.
So F is not my answer choice.
It's either H or J.
Now I'm down to H or J. Do we agree that we have groups?
Yes.
Do we agree we have equal groups?
No.
There's 3 here, 3 here, 3 here, 3 here, 3 here. 3 here, 3 here, 3 here, 3 here, 3 here. Okay. How many groups are on H?
5.
5. Okay. How many of those groups are shaded?
1.
Okay, so is that 3/5 of that 15?
No.
Okay. So, probably not going to be H. On J, how many groups do I have?
5.
How many groups are shaded?
3.
3/5. So, my answer is
J.
J. In a minute, I'm going to come back to show you how you could also figure out the answer if that was a little confusing. But I want to get through the pictures and I'll show you standard algorithm. Okay? We're going to come back to 2. Go to 3. Okay, so it says D worked for 3 weeks. The shaded parts of the model represent the fraction of each week she worked from her home office. Which expression can be used to determine the number of weeks D worked from her home office over these 3 weeks? When we think of multiplication, what is it similar to? Adding. So I could add over and over again. So if it was the problem 3 times 4, I could do 3 times 3 times 3 times 3, or 4 times 4 times 4, right?
Yes.
Okay, so look, so I know that it says she worked from home for 3 weeks, right?
Yes.
Okay. Looking at week 1, how much did she work?
3 7.
Okay. Week 2, how much did she work?
3 7.
Okay. And week 3.
3 7.
Is the amount that she worked each week the same?
Yes.
Okay. So if it's the same, what could I do? I could add. I could do 3/7 plus 3/7 plus 3/7.
9 7.
Okay, but what else could I do?
You can multiply.
What could I multiply?
You can do 3 7 times 3.
Okay. What else could I do?
You can do 3 times 3 7.
Yes, 3 times 3/7. Does order matter when you multiply?
No.
Does order matter when you add? No, it does not. So looking at A, what is wrong with A?
It
multiplying.
So let's talk about B. Is this the correct addition expression for it to be the right answer? No. 3 plus 3 sevenths is different than 3 sevenths plus 3 sevenths plus 3 sevenths. So this is wrong. C is the correct operation,
But it's not the same
but
denominator.
it's not the correct fraction.
So your answer is D.
My answer is D. We're going to come back to 2 in a minute. Let's go to this paper real fast though.
Bless you.
Okay, I want you to write that down.
Yes, ma'am.
Yes, ma'am. Is that or?
Of 2/3 of 12 or 2/3 times 12. Okay, we ready to move on?
No, ma'am.
Yes.
So, are these the same problem?
No.
No.
Yes.
Okay, why do you say no?
Because it's saying like, and then like on the other one, you're like it has the sign, and then the other one has like words probably.
Okay.
I think
What do you think, Lauren?
I feel like yes, they're the same because the same too. Like the less.
Emily?
I think it's because I think it's not because of could be like 3 over 6 plus 12.
Okay, so you think of means to add.
Yes.
Okay. What do you think, Trayson?
I think of means to subtract.
Okay. What do you think, Peyton?
I think how like of is like another like one of those pictures like we saw before, but it's like there needs to be 12 of them, and then there needs to be like 3 boxes.
So you did see on the other paper, what operations were we doing on the other paper?
On the other paper we were doing.
Multiplying and addition.
Yes.
We said addition because it's like repeated addition, right?
Yes.
But we're mainly talking about what?
Multiply.
Multiplying.
So yes, so of means multiply.
So you're saying they're both the same?
Yes, they're both the same. So multiplying fractions is pretty straightforward. On adding and subtracting fractions, what's super important?
Multiplying.
Adding, subtracting fractions, what do you have to have?
Equal denominators.
Common denominators. When you multiply or divide fractions, you do not need to have common denominators. Okay? So, the first thing you're going to do is rewrite the whole number as a fraction. So how would I make 12 a fraction?
12 over 1.
Yes. So I'm going to rewrite this problem 2/3 times 12 over 1. Step 2 down here says what?
Multiply the fractions, multiply straight across.
So to multiply fractions, all I'm going to do is multiply straight across. So 2 times 12 is,
24.
3 times 1 is,
3.
what kind of fraction is that?
Improper.
Okay, so if it's improper, what am I going to do? Divide, yes.
It says 3. Says 9.
3 within a 24, how many times?
8.
8.
Yes. 8 times 3 is,
24.
do more problems back here at my back table. Is everyone done with that page?
No, ma'am.
Yes.
So we're gonna look at number 2 again on the other page real fast. Okay. The names of 20 students in Mr. Jefferson's 5th grade class are listed in the chart below. Mr. Jones noted that 3/5 of the students have brown hair. How many of Mr. Jefferson's students have brown hair? Okay. Do y'all want me to do this with y'all or y'all want to do it before I do anything?
Do it with you.
Okay.
Wait, do it by yourself.
Do it with you. Do it
by yourself.
Let me walk you through it, and if you want to try to do it by yourself, that's fine, then you can check, okay? So, if you look at this picture, the students are in lists, right?
Yes.
When you look at that list, how are they separated?
And fourth.
And four.
There's 4 this way, okay? But how many rows of them are there?
Five.
There's 5. Look at my fraction. What's my denominator of my fraction?
Five.
So can I just say I want 1, 2, 3 of those rows for 3/5?
No.
Okay. So let's say no for now. What expression, how would you go about solving this problem then? How many students do I have?
20.
20. And how many of those students have brown hair?
And 3/5.
3/5.
Okay. So
20 is
3/5 of 20. What can I replace that of with?
Times.
Okay. So that's my problem now, right?
Yes.
How do I make my whole number a fraction?
20 over 1.
20 over 1.
Very good. To solve this multiplication problem, I'm going to multiply across 3 times 5, 3 times 20 is
60.
60. 5 times 1 is what kind of fraction?
Improper.
What do I need to do?
Divide.
Okay. Can 5 go into 6?
Yes.
Yes.
Can 5 go into 6?
Yes.
Okay. 1 times 5 is
5.
after I bring down,
5 goes into
I'm starting over. 5 goes into 10.
2 times.
2 times 5 is 10. Subtract. Do I have anything else to bring down?
No, ma'am.
So my answer is
12.
okay. Let's go back up to these 3 of the 5 rows I circled. If I count the names, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. How many students do you get?
12.
12. So if you have a picture that's set up like that, use it.
Yes, ma'am.
If you don't know how to use the picture, can you still multiply like this?
Yes.
Yes.
Do you have a video on your YouTube channel about this?
I'll put it up there tonight.
Yes.
This one right now.
Oh, I'm gonna watch it tonight.
Okay, let's do this real fast. 3/5 of 15. What can I replace of with?
Multiply.
Okay. How do I make 15 a fraction, Noah? Grant, help him out. How am I going to make this 15 a fraction? What have we done on the last 2 problems? Help him out, Zoe.
got a 1 on the bottom.
I'm going to put a 1 on here. You have to know how to make fractions a whole number for this unit. You need multiplication and division. Okay, now I'm going to do what?
We're going
To
to multiply.
Multiply across. 15 times 3 is
45.
very good. 5 times 1 is
5.
And then you divide.
I'm going to divide. It's an improper fraction.
And 5 can go to 45 9 times.
Okay. 9 times 5 is
45. And your answer is 9.
okay. So now I'm going to figure out which one of these has 9 shaded. 1, 2, 3, 4, 5.
No.
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 1, 2, 3.
No.
1, 2, 3.
No.
1, 2, 3, 4, 5, 6, 7,
7,
8,
8, 9.
Yes.
So if the picture doesn't make sense, multiply it and see how many should be shaded.
Yes, ma'am.
Any questions on that?
No, ma'am.
Okay. We are going to glue this in.
Yes, ma'am.